Good morning, everyone. I hope everyone had a great 3-day weekend. Uh, what I want to talk about in this video is geometric series formulas. So now, if you remember that there a difference between a series and a sequence is that in a series we add up the numbers. Um, we add up all the numbers in the pattern. In a sequence, we're just listing them out. So what we did last week and the week before, and what we quizzed on last week, was arithmetic sequences and series. So at the end of last week, we started talking about geometric sequences. So now we're going to talk about geometric series. And if you notice that there's two there's two formulas. There's this one, and then there's this one. Okay, this we'll be doing tomorrow, the infinite series one. So it just sounds pretty cool. Like, hey, this is the infinite series formula. It's like, whoa, that's pretty cool. Also, I am using my phone just to, and just excuse me in advance if either I sound weird or very loud or there's loud tapping on the phone. Okay. It is not going to be, it's not the same as this, where you close your parentheses and then raise it to the end. This is no good. Don't do this. It's not really condemned, it's just the misunderstood, It's just like that this needs to go with the R and only the R. If you have it outside the parentheses, you're basically giving it to the entire quantity of 1 minus R. All right, let's do some problems. All right, so here we have the sequence 32, negative 72, 162, negative 364.5. Let's find the sum of the first 20 terms. Again, sorry for the handwriting, guys. So first we want to see, is this even geometric? It is, but, just for a good habit, you should always check. Because when we take the test, hint, hint, sometime very soon, you're obviously not going to know whether it's an arithmetic or geometric sequence. You kind of have to make some, you got to see if there's a common ratio or common difference between them. So this looks like it's to see what's happening. Just take one of these terms and divide it by its previous one. So negative 72 over 32, that's going to simplify to negative 9 over 4. And then to see if there's the same pattern going on, let's do 162 over negative 72, and that's also going to simplify to negative 9 fourths. Cool, so there is a common ratio. We know our R value is negative 9 fourths. Okay, so now thinking about the formula, now let's review. What was the formula? S sub n is equal to a sub 1. And here's how I kind of have memorized it. There's a 1 minus r over here. There's a 1 minus r over here. Except this one is going to be in parentheses, and we're going to have the r is going to have an n exponent. Okay? So, I know. Now, what's cool about the geometric series formula, as confusing and as complicated as it looks, what's cool about it is I don't really need to know what my last term of the sequence is. If I want the sum of the first 20 terms, I don't need to know what a sub 20 is. I don't need to know what that last number is. All I need to know is how many numbers are in the pattern, what the common ratio is, and what a sub 1 is. So we have 32, 1 minus. Now, watch what I'm doing here carefully. I'm putting this in parentheses and I'm raising it to n, which is 20, because they want the sum of the first 20 terms. All over 1 minus negative 9 fourths, okay? Okay? Now, I would go ahead and just plug this into your calculator the way you see it. I would probably put on the calculator, put another set of parentheses here, and then make me another set there. The reason is you kind of want to be careful with this because some people, what they do is they change these to a plus because in the denominator you're subtracting a negative, which is cool beans. It's all good. But some people want to go ahead and do the same thing over here. Now over here, you can't really do that yet because this part has an exponent. So we don't know if that negative 9 over 4 is still going to be a positive after it's raised to the 20th power, which it won't be because it's an even exponent. So just be careful. You know, don't change that. You can change the bottom ones. If you're uncertain, if you're not sure what's condemned and what isn't, I would just go ahead and plug this in the calculator the way you see it. Okay, or just follow order of operations in the numerator. You can just put the numerator part in the calculator first. That's another option. So let's go ahead and see what happens. Okay, so we have 32, and then in parentheses we have 1 minus parentheses negative 9 over 4, close parentheses, to the 20th, to the 20th, excuse me. Oh, delete. Let me press the right arrow, close parentheses, and we get that. Now I'm dividing this by, and let me put this for quantity, 1 minus negative 9 over 4, or 1 plus 9 over 4, and we get that. Let's see if this will turn into a fraction. It does not. So, ladies and gentlemen, the sum of your first 20 terms, I know it does not look like that, but it's this. Okay? So, now over here. Now, another option you probably could have done, I am not sure what's going on here. So, so S sub 20 equals negative 1. What is that, 10 million? No, 108 million. Negative 108 million, 872,185.3. Okay? That's our sum. All right, now keep in mind, we also could have done this. We could have wrote this in sigma notation, and over here start with n equals 1 going up to 20, and then you would write the explicit formula of that geometric series. Which would be a sub 1, which was 32, and then negative 9 over 4 to the n minus 1. Okay? And I believe, well, I believe if we did that, we should get the same answer. And then what was this? Negative 9 over 4 raised to the n minus 1, close parentheses, and whoa! Oh, I see. Probably needs to be done like that. There we go. That was a little weird. Okay, so yeah, we get the same answer. All right. So you can use the sigma notation. You can use that. So you can use the sigma notation, or you can use the geometric series formula. I would I almost always recommend using that formula just because, or at least trying to remember it, because it's going to help you with this one, which we will be doing tomorrow, and you will be doing this next year. All right, guys. Your homework is going to be posted on Classroom. Hope this video helps, and I hope to see you all tomorrow during our Zoom session. Have a good one, everyone.